Hello, today we're going to go over the notes 5.2.2. What is a logarithm? Defining the inverse of an exponential function. The learning target was to rewrite expressions and equations using the definition of a log. So if we remember from our last lesson, definition of a log is that the base of the log raised to this exponent on the other side of the equal sign equals whatever's next to the base right here. So this would be b to the power of y equals x. B to the power of y equals x. So going from log to exponential or from exponential to log, that's the process. And they are equivalent expressions. In today's notes, we had two tables and we had to figure out the pattern that is in both of those tables. We figured out that the pattern for the first table was a base of 2, and then g of x is the exponent. So for example, 2 to the third power is 8. Okay, 2 to the second power is 4, and so forth. We realized that there aren't any exponents that give you 0 or a negative. Okay, so that's why they do not exist. And some of the answers are decimals. So to go again from exponential to logarithm, you write the log base 2, and then 2 to the power of g of x equals x. So you kind of draw those arrows to help you out. Here we're just making a note that you cannot get -1 and 0. They do not exist. And some of the answers are going to be decimals. We got this decimal by guessing and checking on our calculator. But the calculator can also, if you rewrite this as a log, the calculator can calculate what this log expression is equal to, and that equals about 4.65. The second problem, it was the same thing, but this time the base was 5. Exponential form is x equals 5 to the power of g of x. When you turn this into a log, it's going to be log base 5 of x equals g of x. Again, the exponent goes in front. Here we have the actual graph of a log. If you graph these points, you're going to get this graph, okay? Notice how it has an asymptote on the y-axis because it doesn't go negative or touch 0. It gets close to 0, but it doesn't touch it. And it goes infinitely up and to the right. It keeps going up, even though it's going up very slowly. On the backside, we have some log expressions that we have to figure out what the answer is. So log base 2 of 32 is asking what power do I raise 2 by to get 32? And if we remember our powers of 2, 2 to the 5th power is 32. This one, to what power do I raise 2 by to get a half? 2 to the -1 power gives you a half. Remember, negative exponents give you a fraction as an answer. Log base 2 of 4, this is the same as saying 2, because 2 to the second power gives you 4. 2 to the second power gives you 4. There's no way to get 0 when you raise 2 to any exponent. You cannot get 0. 2 to the third power is 8. 2 to the 1/2 power is square root of 2. Same thing as half exponent is square root of 2. 2 to the question mark power is 1 over 16. So we're going to have a negative exponent because this is a fraction. It should be -4 because the denominator is 16. So 2 to the 4th is 16. Negative because it's a fraction. 2 to the 0 power is question mark. So anything to the 0 power is 1. The next problem we did was determining the inverse equation of each of these and write it in y equals 4, meaning the y has to be by itself. First step is to flip the x and the y. So you write x's where you see y's, and you see write y's where you see x's. Okay. So after you do that, you can rewrite this as an exponential that will get you the y by itself. So once you flip the x and the y, then you can rewrite this as an exponential as 9 to the power of x equals y. 9 to the power of x equals y. Okay. If you have more than one thing in the log, that's fine. You're still going to go 6 to the power of x equals y plus 1 after you flip the x and the y. And the y plus 1 is going to be on the other side. You just have to subtract 1, and that gives you your exponential function. When you go backwards, when you go from exponential to log, you're going to write log base 10 of x, and the exponent goes on the other side of the equal sign. Finally, we did some log problems where log base 7 of 49, that was easy, it's just 2. And log base 3 of 81 is 4. The important part right here is that when you have a base, the bases are the same, you can cross them out, and the answer will just be the exponent. So log base a of a to the x, the log a and a cancel out, your answer is just the exponent.